Okay, so what we have here is our best guess at what will be in the paper 3 for Pearson exam, the main topics that will be scoring most of the marks. So you could use this as a practice for all the types of questions that are left to be asked in Tuesday's exam. So all we're going to do this time is I'm just going to show you the questions, and then you can stop the video at any time and do the questions to practice, and then at some stage during the video I'll show you the answers, and it's not going to be one of these talking videos. It's going to be show you the questions, and then the answers will be later on. Okay. I mean, the main thing about this is that you would stop the video and do the questions. So you stop the video, see the questions, do them, and then go to the particular time that I tell you, and then you can do the questions themselves. Okay, so we're now going to just show you the answers written. Very few explanations, guys, because the answers hopefully will show you the written reasons. Again, stop the video at any time to be able to read through how the answer was arrived at, what method was shown if necessary. I think the key things with questions like question 6 is when you're doing ratio questions, headings, think about the totals if there's any other numbers given, and then you can then see how you can get the answer from that. The percentage, this is fractions. So we know a fraction looks like one whole number over another whole number. Just look for the numbers in the question and then simplify down. You've got calculators, so you literally just type it in your calculator to simplify. When you're writing formulas, really important, you remember that you need an equal sign. You need a subject letter, that means a letter on its own, and then a series of terms with other letters and numbers, and that will be a formula. The thing about congruent shapes is to remember that it's all about the angles and the lengths being the same. So on this one we can see that that angle and that angle are going to be the same. This angle and this angle and this angle and this angle is going to be the same, and then this angle and this angle are going to be the same. So that's why those two would be congruent. Also the side lengths are identical. So that side is identical to that side is identical to that side, and that side is identical to that side. So just remember about congruency, that it's about all the angles in the shapes being the same and all the lengths being the same. Excuse me. When you're simplifying expressions, and it's quite easy to think of the numbers first, and that's why we ended up with 3, and it's a division, so we have the division line, and then we're doing a d divided by d to the power of 5. Well, that means you end up with d to the power of -4, which is actually 1 over, because the negative says it's a fraction, so it's 1 over d4, and then we just had the b squared left. So that's why we ended up with this. You could write it as the negative powers, because I say negative means it's a fraction, 1 over. Using formulas, well, we need to remember all we're doing is putting numbers in. So just follow the formula. Just remember to have the same units when a question wants an answer in pounds. If you've got 50p, turn it into 0.50. Meter reading questions, just remember that you have to do a takeaway to get the number of units used, and then just follow the instructions of the question. So normally not too bad. Names of shapes, make sure you know all your shape names, and the vertices are the corners of the shape. The edges are the lengths between the vertices, and the faces are the surfaces between vertices and edges. Making something the subject, just remember you do the opposite operations to move everything from one side to the other, and the subject letter has to be positive, so it's already positive here, so that's why we've moved everything away from the M. The reciprocal, just one of those odd words that means you multiply something to give you an answer of 1. So basically I want the reciprocal of 5, so it's 5 times something to give me an answer of 1. So I can divide by 5 and that will give me the answer. So basically 5 times 1/5 equals 1. So the reciprocal is a fifth. Drawing accurately, the main thing to remember about drawing accurately is be accurate. Get your head over the ruler like a plan view, get your head over the tractor like a plan view, and make sure you draw as accurately as you can. The starting point with this one would be the bottom line, so that's 8.5 centimetres. And then you draw your angles carefully by putting your protractor on and making sure that you line your protractor up carefully. So remember, it's important that your protractor has 0 on there, the centre on there, 0 on there, and you're measuring round in a going up direction, 10, 20, 30, 40, 50 degrees. So it's really important that you use your protractor carefully. And then you measure your 68 degrees and so forth, put your dot, 35 degrees the other side, put your dot, and then we don't know how long the lines are going to be, so we just draw them until they meet, and that makes the triangle. And we can check by measuring the top angle there, because we know the angles in a triangle add to 180. Proportion. We've got to remember that direct proportion means that the two variables, when you divide them, will give you the same number all the time, called the constant of proportionality. And when we do the division of the variables here, we can see that we don't get the same number all the time, so therefore they can't be in direct proportion. Also, graphs of direct proportion will always start at 0, so try and remember that as well. And because, I say, the ratios don't give you the same constant number, then they're not in proportion. If we had to find missing values in the table, then if they tell us they're in direct proportion, then of course we've got to just do a division to get the constant, and then we can see how to multiply up. If it's indirect, then basically as one variable increases, the other decreases. And we've just got to remember that for indirect proportion, the two variables would multiply to give you the same number. So you choose any coordinate on there, then the constant of proportionality is the y coordinate times the x coordinate, and that will always be the same. So anywhere on this line, take the y coordinate and the x coordinate, multiply them, it will always give you the same constant. So that's inverse indirect proportion. When you're doing these questions involving going back to an original price, then a little flowchart to kind of remind yourself what's going on. We've got an original price which we don't know, and we've added 18% to it. Well, that's the same as increasing by 1.18, which is called the percentage multiplier, and that gave the answer of 1475. And of course we need to go back to the original price, so we do the opposite of times it by 1.18, divide it, and then we get the answer of 1250. It's a calculator paper, guys, so it's quite a quick method with a calculator. Formulas again, just be careful that you follow the words carefully. It says as a bonus, if they get to work so many hours and 7 hours, then we're going to be in this column here, so we get a bonus of 20 on top of the £8 per hour. I think there was an error in this question, because we took it from a past exam bank. I think it should have been 70 or something, because £50 just doesn't work. So I think there was an error there, so apologies for that. So I've just worked it as if it was £70, and it's the usual thing, guys, when you get formulas. If they give you a number for this side of the formula, then it's about doing the reverse of the formula, so that you can get back to something inside. Solving what I call double equations, where you've got the unknown in two terms. Classic thing, you deal with the x terms first, or whatever letter they've given you. So I'm going to take away 4 x's to make these x's lower but still positive, and then once I've done the x's, I then do the numbers, and I end up with so many x's equal a number, and then you do the division at the end to get the answer. And we really should check that they actually work. Finding missing angles, got to be one on the paper, I suspect, because it's quite a popular topic. So basically we can see from this picture that we've got parallel lines, and then when we get parallel lines we should be thinking of these where we get the alternate angles, we get the corresponding angles, and we get the co-interior angles. And the co-interior ones add to 180. So the corresponding angles are equal, alternate angles are equal. So when we follow this picture, we can see that if we follow this trapped angle here, follow down to the next parallel line, we can see that we've got a backwards f, and therefore that angle must be the same as that angle. And then we've got angles on a straight line. Told this angle because it's vertically opposite, angles are equal. Angles in a triangle, and then we can get x. Again, it had asked you to give reasons, so it must be given reasons for every time we do a calculation or every time we put a number on the picture. This question asked you to work out where A, B, C, D will be on this grid. They told you that it was about the area of the shape, and we can see that they've already given us the length between A and B of 4, so therefore if the other side must be 3 for a rectangle to give you 12 square centimetres. So we just basically come down 3 and there we can make our rectangle. So it says draw a rectangle, so with our rulers really we'd finish off drawing the rectangle. And that would be the answer. We could have drawn it this way, so the rectangle could have been above, so there is an alternative answer as well. So then it says write down the coordinates. Well, always remember coordinates. You go along the x-axis first, take a number, and then go up to the y-axis number, and then read them off. So C will be 7 across for 7, and then 2 up to get to it. The midpoint of a line, then you're always thinking of adding the 2 coordinates and halving the answer. So if I want the midpoint of line AC, then I'm going to think about A, think about C, and I'm going to do the middle. I could have drawn the line AC on, and then that would have been the midpoint, and then I could have just read it off. So there's lots of ways you could do that question for the midpoint. These graph questions, when you got to draw one, just remember you've got your calculators, but substitute everything with brackets to make sure that you put your numbers in your calculator carefully. So something to do 2 times the number here, 2 take away 3, and that will give you -2 and so on. So once you've got your points, then we know it's a quadratic because this multiplies out to x squared, take away 3, and you should get the classic U shape. And when we plot the points and draw it, we do. And then the question goes on and asks us to read off some values. It says, what's the turning point? Well, the turning point is where the gradient changes from one direction to the other. So it's there. And that's a coordinate 1, 5, -2.4. Read the scale carefully. And when it says the word roots, then it means that you want to find where the graph crosses the x-axis. So it crossed at 3 and 0. And if we put 3 into here, we can see that 3 squared is 9, take away 3 times 3, which is 9, and 9 take away 9 is 0. So that's why they're called the roots, because it gives you an answer of 0 when you put it into the function. Stem and leaf diagrams, just got to be careful that you remember you have a line, and then this side is, in this case, the tens, and in this side it's the units part. If these numbers were in the hundreds, then this would be still the tens column, this would still be the units, but you'd be starting with 10 if it's like 100, 102 and that kind of stuff. Then this would be like 10, 11, then that would be 10 tens, so forth. Always remember the key, really important guys. If they haven't given you a key already, then it's worth one of the marks. When you're interpreting a stem and leaf diagram, just remember that the numbers are in size order already for you. So if they ask you to do things like the median, you're literally counting up until you get to the middle of the numbers. So here we can see that there are 13 cars before the middle position, and then there's 13 cars after it, which means 6 is in the middle, but that's 6, remember, from the key. 5 and 6 makes 56. The range, always highest value in a list of numbers or in a table, take away the lowest value. And so in this case we can see that the highest value is 70 and the lowest value is 38. And we do that takeaway and we get the range of the answers. And remember, the range is about the spread of the data. So if it asks you to do a comparison question, then we talk about the range being the spread, so how far apart the data is, and we talk about the median being a typical average. Fibonacci. Sequences have been done quite a bit in the exam so far, but Fibonacci hasn't been asked yet. And Fibonacci sequences are about adding the previous 2 terms to get the next term. So when we also asked to find these missing ones, then 2 plus 7 is 9, 7 plus 9 is 16, 9 plus 16 is 25, and so on. Another missing angles question to practice. This time we've got angles on a straight line. We've got an isosceles triangle. Really watch for that, guys. Dashes through lines means they're the same length, so we know this is an isosceles triangle, and therefore if that angle is 54, the base angles are equal, so that's 54 and so on. Solving inequalities, the key thing to do is remember to keep the inequality sign and then just follow through the same process as always. We want y as the answer, so we're going to move everything to the right hand side of the inequality sign, by doing the opposite operations, and then we end up with y is less than 7.5. This question asks you to work with a geometric sequence. Well, what we've got to remember about geometric sequence is that every term must be the same multiple of the term before. So we look for a timesing factor, and in this case we can see that to get from term to term we always have to times by 4, so to get the next term here we'll have to do 192 times 4. So a geometric sequence is about timesing between each term, and it's the same number. If it's not the same timesing factor, then it's not a geometric sequence. Here we've got the classic question with the percent sign at the end of it for the answer line. So therefore it's always going to be about a fraction times 100. The fraction will involve at the top what the question is talking about, so it wanted the percentage increase. So we work out the increase in the price and then we divide by the original amount. So this bit is always the original value. So this bit here is always the original value, and then that's going to be the change. This question talks about the volume of a cylinder, so we should remember that a cylinder is a prism. So prisms are cross-section area times the length. Well, the cross-section area is a circle, and we're timesing by the length of it. It's fairly straightforward as long as we remember that that's the radius and that's the height, and then we just put the numbers in, multiply through. Remember the question wanted the answer to 3 significant figures, so we find the first non-zero digit, 1, 2, 3. Going to cut the number there. 6 is 5 or more, so that changes up to 3. The question goes on and talks about density, and density has a formula. These triangles sometimes are quite useful to use when we've got 3 letter formulas. And we can see that the question wanted the mass, so we cover up the mass. These are next to each other, so it means that we're timesing them. So the mass is going to be the density times the volume, and of course we've been told what the density is, and we know what the volume is from the previous part of the question. Just remember on cylinders they can actually use surface area. So surface area is when you unwrap the cylinder and you end up with a rectangle and 2 circles, and you work out the areas of those. This question's interpreting a real life graph, so you just got to remember to think about the scale of the graph. The squares across here are worth 12 minutes, and the squares going up here are worth 0.2 of a metre. So just got to be careful that we read off. The question wants you to firstly talk about the depth of water at 1300, so we draw a line up and read off, and it's very straightforward. 2 metres, so go for 2 metres and come back down and read off. It's halfway between, so 1030 and so forth. And the rest of the question you just follow in this advice. So same rate, same gradient. So we just extended the line to get where the time was. And when it says at what rate was the depth of water changing, then the rate of change is the gradient of the line. So we work out the gradient, if you remember, by thinking of a triangle, a right angle triangle, where we need to have a change in the y coordinates. In this case I've chosen to go from 10 till 12, so it's 10 till 12. So the triangle that we're going to use is this one. And we can see that there was a change of 4 metres. Good job I did this again. 4 metres, so that's 4, and that's 2. So this is 4 metres, 4 metres, so therefore the rate of change will be just 2 metres per hour. Okay, so the rate of change will be 2 metres per hour, because that goes from 0 to 4. It goes from 1 to 5. So it's got a change of 4. So just got to read the graphs carefully. Just follow my own advice, guys. So 1 to 4 or 5, change of 4. Okay, so that's how that question could be done. This question is one of those questions where they give you lots of information about various things, but it comes down to 2 basic categories. Here we're talking about girls and boys, and they're doing certain things. So we can either use a frequency tree by following through the numbers. There was a total of 100 people altogether. They were split between girls and boys, so we can work out how many girls and how many boys there were, and then they told you various information that you could fill in for each of the subjects, and then you can find the missing numbers. You could have drawn a 2-way table as well and put in the numbers they tell you in the question, and then allow yourself to find the missing ones by doing takeaways. Again, you still come up with the same answer of 28, but when you get these kind of questions where there's lots of information about 2 categories, then either a frequency tree or a 2-way table will be the easiest way to find the answers. Questions involving polygons. We know we've got polygons here because they're talking about pentagons, hexagons, nonagons, all those kind of different polygons. And they're talking about an equilateral triangle, which is a special polygon. Then there's various rules that happen for these shapes. And the main rule to remember is that the exterior angle of a polygon that's regular is going to be 360 degrees divided by the number of sides. And in doing that calculation, we can see that for this particular shape, pentagon, the exterior angle is 72 degrees. That means the interior angle will be 108. So everyone's the same because it's a regular polygon. So we can fill in some of the numbers already. And then we can see that equilateral triangle, all the angles are 60 degrees. And then we've got 360 around this point. And therefore we can do a takeaway and get the answer for the question. But the key thing about polygons is to remember this formula. And then the interior and exterior angle must add up to 180 degrees. So because those add to 180 all the time, whether it's regular or irregular polygon, then you can get the missing angles. Okay, this question asks you to firstly translate. So translation means that we're going to move the shapes either right or left and up and down. If that was a -8, then it would have gone to the left instead. So basically when you're doing your translations, you choose a point and then you move that point 8 along, 3 down. 8 on the scale, remember, and 3 down on the scale. So look at the scale and make sure you're not just counting squares, because they have asked in the past questions where the scale was not 1 per square. So be careful, it's about the numerical scale, not the number of squares. As it happens, each square is worth 1 in this case, so it would be by squares. So 8 and down 3. The question then goes on and says to do a enlargement by a scale factor of 1/3 on a particular centre. So you mark the centre and you draw a construction line. You then measure the distance between the centre and that construction line to the point on the shape. And it was 6 diagonals. So going across here, I went across 6 diagonals. So I do 1/3 of that by dividing by 3. So my new shape is going to start 2 diagonals away from the centre. And then basically this had a length of 12, and if I do 12 divided by 3, I get 4. So that's why that had a height of 4. This had a length of 6, so this would have a length of 2, and so forth. So that's how we would do centre enlargement from given centres. This question asks you to work with bearings, but it said it's not drawn accurately, so it wasn't a case of getting your protractor out and measuring this one. So no protractor on these kind of questions where it says not drawn accurately. So it's about using your angle theories, and we know that a bearing is where you measure from north being 0 degrees, but the bearing of course will be 0, 0, 0, and you measure around clockwise if you had a protractor, but in this case you didn't, so therefore we've got to work out what this angle will be using some angle theories. It said it was from B, so that means we're going to put the north line at B, and when we look through the information we can see that we've got a vertically opposite angle here which are equal, so that's 68 degrees. We know that an angle in a triangle adds to 180, so we can work out this missing bit here as 22 degrees, and then the bit that's left to go from north at 0 round to there must be 180, take away the 22, and hence the reason the bearing was 158. And because the bearing is 158, it's already got 3 digits, so we can leave it as 158. If we'd have done the bearing and this answer had been 72 degrees, then we must remember the bearing would be 072, 3 digits. Okay. These questions where you're converting units in volume or area, then you've got to kind of think what the area or the volume would be in the original unit. Think about how you convert each edge length, and then you can then work out the new volume in the new units. So here we've got a centimetre cubed, it's centimetre by centimetre by centimetre. If I turn that into millimetres, we know that 1 centimetre is worth 10 millimetres, so it'll be 10 millimetres by 10 millimetres by 10 millimetres. That gives us, when we multiply 1,000 cubic millimetres, is equal to 1 cubic centimetre. So when we're converting from here to here, then we literally end up dividing by 1,000. So we divide by 1,000, and hence the reason we get the answer of 4,500. This question was about bearings, and this time it's about scale. They've told us it's accurate, so we can use a protractor and a ruler. And because they've got that scale, then the first thing we're going to do is we're going to convert all the lengths they're telling us into a ruler scale. So if every 2 kilometres is a centimetre, we can divide all the kilometres by 2, and that'll tell us how many centimetres to use. Bearings was about getting your protractor, lining up north with 0, and then measuring the angle round at 127 degrees, then getting your ruler and drawing the line 13.5 centimetres long to get to the new point A. And then once we're at A, we draw a new north line and then follow the rest of the instructions. And then once we're at X, we draw a new north line, follow the instructions for the bearing, and then we end up at all the points we need to. Okay, so that's what your picture should look like, guys. And when we want to do the final answer of what's the bearing for ship B from the helicopter, well, the helicopter was at X, north line, measure 300 degrees round, draw the line, and we measure the line, sorry, we had to measure the angle. So our protractor only did 180, then we turned the protractor around and we can see that we needed another 120, and when we add those two together we got the 300 degrees for the answer. Okay, so this question talked about having different items sold in different quantities. So we wanted to know what she could do. She wanted the smallest number of packs of hats, toys and bags. So if she wants the smallest number, then she needs the same number for any multiples of these. So basically we're looking for the lowest common multiple of 8, 9 and 12. So if we go through the list of the 12 times table, the 8 times table, the 9 times table, we can find that 72 appears in that. So therefore she's going to buy enough packs of all of these to get 72 altogether of each, and therefore she can make 72 party bags. The question says how many more than the 70 she wanted, so she can do 2 more. So basically remember that you have to answer the question itself. So we tick off we've done that, and then you get the answer you wanted. This is one of those questions that involves a picture with loads of x's on it, so it really comes down to creating an equation. So we're looking for what connects the x's, and we can see here it talks about the word perimeter, and we know the perimeter means that we add up the lengths around the outside of the shape, or wherever the edges are. So the edges could be inside, of course, and that's still the perimeter. So the perimeter will be the added the edges up. So when we add the edges up, we see that it equals 38, and we end up finding the x value. Then we replace the x in each of the lengths that they give us in the picture. We don't need to do this one, remember, because the trapezium formula tells us that we only need the parallel lengths. So these are the 2 parallel lengths, and once we've got the parallel lengths, we can then work out the area from the formula, and we find it's 80 square centimetres. Okay, solving simultaneous equations, the key thing about those is to remember to go through the process of making one of the letters have the same number in front. We can see here that if we just multiply this one by 3, then we'd have a 3 in front of that y, and then all we've got to do is think about how do we cancel this to 0. Well, if we want to make negative 3y and plus 3y become 0, we have to add the equations. Sometimes you've got to do the takeaway. It depends on what you've made, what letter you've made to have the same number in front. If they were both positive, for example, you'd end up doing a takeaway, and if they were both negative, you'd have to do a takeaway. Anyway, in doing the adding, we can find we get the value of x, and once we know the value of x, we put it into one of the equations to find the value of the other letter, and then we do a check at the end to check that it works in the other equation, the second equation. And those 2 values are the answers for this particular question. Grouped information, so remember these are called intervals because they're going between 2 numbers, class intervals, and when it wants the median, then we've got to find the middle child, and because it's an even number of children, then this time the middle will be 2 children, and then we want to be in the middle of that. So we need the 20th and the 21st child. So we can see by adding up the frequencies that we had 3 children up to here. At the end of this interval we'd have had 11 children. At the end of this interval we'd have added 7 more children, so we've got 18 children. And then the 20th and the 21st would be in here, because this has the 19th, the 20th, 21st, 22nd and so forth. So the answer for this will be the interval 3H4. The question goes on and asks you to work out an estimate for the mean average. Well, what we've got to remember about estimating the mean average is that we still need a total. Now it's asking us for the number of hours, so therefore we need a total number of hours. So we have to do that by using the midpoint of the interval, because we don't know exactly what these 8 children did. We just know they said they watched between 1 and 2 hours. So we use the midpoint as a good guess, a good estimate. So 1.5 is in the middle of 1 and 2, times by 8 will tell us that these 8 children roughly watch 12 hours of TV between them. And we do that the same for every row, and we end up with a total number of hours. Because the mean is going to be the total of the hours by doing the midpoint times the frequency, 120 was the total, then we're going to divide that by the 40 children and get 3 hours per child. It's always about dividing by the number of numbers in the table, and the number of numbers in the table will always be found by adding the frequencies. So we'll get 40 here, and then you always end up dividing these two numbers. So we have two totals to do the estimated mean. And this answer was 3 per child. Okay, trigonometry has not been asked yet, so we've got to remember to look for right angle triangles in pictures, and if it's got an angle involved, or you're finding it or using it, then it's likely to be SOHCAHTOA trigonometry. Write out the SOHCAHTOA, find out what you know already. Well, in this question we already know the adjacent length because we've labelled this as theta, gone round and labelled the triangle as opposite length to theta. Hypotenuse is always the longest length of the right angle triangle, opposite the right angle there, and the adjacent is always next to the angle. So we go through labelling up, and we can see that because we know A, we can tick A, and the question wants you to find the length of AC, which is the hypotenuse length, and so we had to tick the hypotenuse length as well. That means we've ticked that one twice, so we're going to use the cosine. Write out what the rule is for the cosine. It's the cos of theta equals A over H. Put the numbers in that we know for the question. So we knew that the angle was 36 degrees. We knew that the length of A was 8.7 and we want H. So we move H across by timesing because it says divide here. And we move the cos across because we need the H on its own. The triangles can help with this when you want to find missing lengths. So cos theta is A over H. We want H, so cover it up. And we're going to do the adjacent length divided by the cosine. And we end up with 10.8. If you'd have made a mistake here and made this a multiply, then you'd have ended up with an answer that is smaller than 8.8, and that should tell you, sorry, 8.7, and that should tell you that can't be right because you're working out the hypotenuse length and it must be bigger. So always check whether your answer makes sense, guys. Another right angle triangle question with an angle needed this time, so therefore it's still going to be trigonometry, SOHCAHTOA. Label your triangle up, so the angle is always called theta, like you got in the triangle. And opposite the theta, hypotenuse is the longest length, adjacent next to theta. We know O and A, so we tick under O and A. That's the one we've ticked twice, so we're going to use the tangent theta in this question. And so we write out the ratio, fill in the numbers we know, but when we want theta, we always use the inverse function. So on our calculators, when you look at the tan function, you can see above it, it says tan minus 1. Different colour, it's in orange, so we have to use the shift key. So it's shift and that. The thing to remember about this as well is make sure your screen either shows the letter D or the word deg. If it doesn't, reset your calculator. So 55.6 degrees when you do the tan minus 1 of 19 over 3. Tree diagram question. So notice tree diagram question comes up when you want something and something. So if they give you a question where it says what's the probability of A and B happening, then if they haven't drawn your tree diagram, then literally they're expecting you to draw a tree diagram. So far most of the questions have had the tree diagram drawn and you've just got to fill in the missing bits, so touch wood, it's going to be that style. But if they hadn't have done this, then you'd have read this as badminton and tennis, so we'll see what happens for badminton, see what happens for tennis, draw the branches, fill in the missing probabilities. All we've got to remember is that when we come from an event, so playing tennis, then there's 2 outcomes and they've got to add up to 1. 1 is the same as 10/10, so if we take away the 9/10, we end up with 1/10. You got calculators, so you'd have done 1 take away 9/10. And on this one we'd have done 1 take away 2/5, and that's why we got 3/5. So we fill in the tree diagram. It says work out the probability that Hannah will win both matches, so we follow the tree and we see that we get Hannah wins there, Hannah wins there, so we've got to the end here, we picked up these 2 probabilities, and because we want this one and this one, we times the 2 probabilities, and that gives us 9/25. This question talks about drawing a graph. So it's asking to draw the graph of y equals 2x plus 3. So when we want to draw a graph, we have to find some coordinates. It's only a straight line, so 3 coordinates will do. And between 0 and 5, so 0, 5, and then just something roughly in the middle. It's telling us to double the x value plus 3. So we double the x value plus 3, double the x value plus 3, double the x value plus 3. That gives us some coordinates to plot. So we plot those coordinates on the graph, and then draw the straight line between them and label. Always label your graphs, guys. This question goes on and says we want to solve some simultaneous equations, and what we've got to realise about simultaneous equations on graphs is where the two graphs cross is going to be the answer, the intersect. So when we follow down, we can see this is about 2.6, this is about 8.2, and that's the answers for x and y. And basically we check by putting these numbers in. So if I do 2 times 2.6, I get 5.2. If I add 3, I get 8.2. So it seems to work. Okay, so simultaneous equations using graphs, then you draw the two lines. This one was already drawn for you, so that one was already drawn. This one we just drew, so those two crossed at there. The intersect point's the answer, read off. This question was one of those awkward ones. It wanted the total surface area of this shape, but then we've got to realise total surface area means that we add up all the areas of every face. So in this question we had to go through and think about, well, how many faces are there? And when you look very carefully, you can count up 10 faces. So you would sketch out each face, put on the numbers that make the lengths for that face, work out the area of each, and it happens this question was all about rectangle faces, so quite an easy calculation to work out the area of a rectangle, but you have to be careful that you found all 10 faces, so really be careful. Quite often drawing a net of the shape helps you to see how many faces there are, but this one it was easy just to go round counting up the faces. And when you work out the area of all the faces, you find you get an answer of 110 square centimetres. Now, there's no units given on this question, so there was a mark available for the unit. So even if you didn't get the answer correct, you'd have got a mark for making sure you remember to write down the units. Watch for that, guys, because not every answer line has a unit on it, and the examiners are expecting you to put the units there. This question was a more complicated trigonometry question, but again it's possible in your exams to be a bit more complicated than a straightforward triangle. But we can see that the picture's got some right angle triangles in it, it's got angles in it, so it's kind of indicating please use trigonometry. So we've got to find SOHCAHTOA involved. We need some angles, so we can see we've got a triangle here with one angle given, so we know this angle will be 54 from angles in a triangle to 180. It's a parallelogram. They're telling you that because of the parallel lines. So the opposite angles in a parallelogram are the same. We want the length of AD. This is the length we want. That's our question mark. But at the moment, we've got not enough information on this triangle to be able to calculate it. So we have to use this triangle first to calculate O. And when we go through and label up, so the angle's always labelled theta. The opposite length was there, the hypotenuse and the adjacent, and then we follow through this process. That gives us that length there. Sketch out the triangle we're now working with, label up this triangle appropriately, with that being theta now. 6.88 was what we found for the previous one, and then we can go through and do the correct calculations to get the answer. Okay, so that would be a more complicated trigonometry question, but it's possible. This next question talks about exchange rates. So basically my advice is put the headings down for the units that they're working with. So they're working with pounds and euros in this case. Put the numbers in they tell you. Fill in a number that you've got from the information in the question. See what the missing scale factor is. So in this case, by doing 64 euros 0.8 divided by 120, we get 54. So we times it by 54 to find that the handbag would have cost £54 equivalent, and we compare those because the question says to compare. So we knew that the handbag cost £52.50 in Manchester. We have to compare, and therefore we have to have a sentence at the end. So the handbag in Paris was dearer based on the information we have. Although think about the cost of actually travelling to Paris would negate any savings you'd make technically. Okay, this question has got some cuboids involved, and it's asking you to work out how many of the packets will fit in. This question, you could have worked out the volume of both and divided them. but that doesn't always give you the exact answer, because basically they're asking you to imagine that they fit in perfectly in here by the way the question is worded. So the best way of doing this is to change the units all into centimetres so we can work with the same units, and then we basically find how many of those fit in along the bottom row. Well, if we do the 200 divided by 40, we get 5. So 5 boxes will fit along the bottom row. Then we do the side, and we can see then by doing all of that, we ended up with 5 boxes along the bottom, 25 boxes backwards, 4 boxes high. Multiply those, it'll tell us how many boxes altogether. So 500. If you had done volume and then divided by that volume, you'd have still got 500 in this case because they fit it exactly. But remember, fit-in problems, it's all about looking logically about how they fit in, really. Alright, this question talks about inequalities, so it's saying that the value of n is an integer whole numbers, so all the whole numbers are either less than or equal to 1, but greater than -4. So on our number line we can imagine we've got -3, then going upwards, -2, -1, 0, and we can have 1 because it says it includes 1, it equals to 1. This question's about writing an inequality that represents this number line, and when you've got a coloured in circle it means it can be equal to, and when you've got an open circle, so not coloured in but a circle, it's above the number 4, so our limit is 4, but it can only be less than 4. It can't be equal to that because it's not coloured in. It's talking about x, so therefore that's why x is in the middle of this inequality. So x has to be less than 4, but it has to be greater than or equal to -2, so it could be any number in between here. This question was a Venn diagram question involving putting some information into it. They told you that there were 7 people here, which literally means those 7 people both do geography and history. So that's what this question was about, students who study both geography and history. It told you that's 20 students study geography but not history. So this was where the 20 goes, because the circle represents everybody who does geography, but those 7 do history as well. Here they do geography only. And this question says 20 of them do that, so that should be 20. 19 students study history, so the whole circle represents 19 students. 7 of them are there, so that means that must be 12 for this bit here. There's only 12 that do history only. This one says what's the probability. We use this language to mean the probability. So it says what is the probability of G union H? So in other words, what's in G and H or both? And that means adding up everything that's in the circles, and we can see that gives an answer of 39. It wants a probability, so that's a fraction, so it'll be 39 out of the 50 students altogether. The question went on and talked about what's the probability of H dash. Now what we've got to remember is that when it says H dash it means not, so it's not H. Okay, so it's really important that we remember this language. The dash means it's not that, so it's not H. So when we look at this, at those that are not doing history, then there was 19 students doing history, so not doing history was 31. So the probability is 31 out of 50. This question had loads of words. It was talking about 2 items, adults and children, so it's kind of indicating by the fact they've given you 2 statements that you're going to create simultaneous equations. So we write down some equations involving the information. We can see then that we can make one of the equations have the same the same number in front of the letter by timesing this bottom one by 3. We can make this have 3a in front of it, and then we do a takeaway in this case because 3a take away 3a makes 0. So 9c take away c is 8c, 66 take away 30, and so forth. That tells us the answer for the child ticket cost, and then we put the child ticket cost into one of the equations to find the adult ticket cost. So reasonably straightforward simultaneous equations, as long as you remember to be careful about how you cancel out the letter that you may have the same number. If they're both the same sign, then you do a takeaway. These were both positive, so we do a takeaway. If they were both negative, we'd still do a takeaway. If they're 2 different signs, then we do an add. Excuse me. Okay, so they've already done a question involving circles a little bit on the first exam, but there's still sectors, parts of circles, so it's still worth remembering the formulas for these, because if they're going to ask them in a foundation paper, then it should be a fairly straightforward question where it's just an ordinary sector involving an angle and a radius. And if we know the formulas, then it's fairly straightforward just to put numbers into the formulas. So they're telling us that the angle of this sector is 150. We know the radius is 13 from the way they've drawn this. O is always the centre of the circle, so that's the radius. If they ask you for the arc length, well, there's another formula for arc length, and then you'd literally again just know that you need the angle of the sector and the radius, and the arc length is just this part here, isn't it? It's the arc part of the circle circumference, so it's that part there. Okay guys, so that's some practice questions to get you going. Likely to be those topics in your final paper that'll score the highest marks, so it's worth practicing them well.